Hi everyone, welcome to the question session of nuclear chemistry. On this question session, totally 2 to 3 videos will come. If you have any doubts still regarding nuclear chemistry, everything will be cleared in this question session, right? And I'm going to give you the solution here only, right? I will just read out the question and write here only the important data of that particular question and explain the solution. Okay, right? So the first question is loss of beta particle is equivalent to, the first one is loss of beta particle is equivalent to, so loss of beta particle is equivalent to first option, increase of one proton only, right? So first of all, for suppose I'm taking carbon 614, right? Loss of beta particle is equivalent to means here beta particle is emitting, loss of beta particle. I don't know which nuclei here forming, so I'm writing ZA. So this is the question, right? So loss of beta particle is equivalent to first option, increase of one proton only, second option, decrease of one neutron only, third option, both A and B, fourth option, none of these, right? See here, first of all here Z minus 1, here 6, so 6 equal to Z minus 1, Z equal to 6 plus 1, 7. So here in place of Z I get 7. Okay, next 14 equal to A plus 0, that means A equal to 14, A equal to 14. Okay, so now what happens, first option, increase of one proton only, here this is the proton 6, here 7, so increase of one proton plus 1, of course first option is correct. Second, decrease of one neutron only, 14 minus 6, 14 minus 6, 8, right? 14 minus 7, 7, 14 minus 7, 7, here 8 neutrons, here 7 neutrons, so decrease of one neutron, so this is also right. So option A and B, both A and B are correct, increase of one proton and decrease of one neutron are there here. Okay, this is the first question. Second question, thorium 90-234. The first one is thorium 90-234 on disintegration to give lead 82-206, to give lead 82-206. Total number of alpha and beta particles emitted out during this process. How many number of alpha particles and how many number of beta particles are emitting in this process? We can do this question in 2 ways. So the first we can do by using the formula. Okay, I have already given you the formula. So the first formula, number of alpha particles equal to, here mass number 234 minus 236, right? 234 minus 236, 28, right? 28 by 4. This minus this by 4, so 7. So totally 7 alpha particles, 7 alpha to 4. Number of beta particles, 2 into alpha, 2 into 7, minus 2 into alpha minus 90 minus 82, 8, right? Z1 minus Z2, I have already given the formula, 2 into 7, 14, 14 minus 8, 14 minus 8, 6. So 6 beta particles, 6 beta particles. So options are, how many number of alpha and beta particles combinedly, right? How many number of alpha and beta particles? The first option 6, second option 7, third option 8, fourth option 13. So here 7 alpha particles and 6 beta particles, totally 13. So this is the correct option. Okay, so I can do this question in another way also. See how many number of alpha particles are there and how many number of beta particles are there, right? So 90 equal to 82 plus, here how many number, x, here y, right? So 82 plus 2x minus y, minus 1 into y minus y, 2 into x, 2x. Okay, okay, so how many number of beta particles are there? So now 2x minus y. Okay, so first of all we calculate this. 234 equal to 206 plus 4x plus 0y 0. 234 minus 206 28 equal to 4x, x equal to 7, right? So 7 alpha particles. 7 alpha particles. Now do this. 90 equal to 82 plus 2 7 is 14 plus minus 1 into y minus y. Okay. Now 82 plus 10 92, 92 94 96. So 90 equal to 96 minus y. 90 minus 96 minus 6 equal to minus y. Minus minus get cancelled, y equal to 6. So 6 beta particles. So in place of y I can have 6. So this is the second method. Okay. So this is the answer. So total alpha and beta particles are 13. Next one. Next question. Isotone of germanium 7632. Germanium 7632. Isotone of this. Isotone of this. What is the isotone of this? First option germanium. First option germanium 7732. Arsenic. Second option arsenic 7733. 7733. Third option selenium 7734. Fourth option selenium 7736. What is the isotone? Number of neutrons same, right? Number of neutrons same. Okay. So first of all 76 minus 32. Here how many number of neutrons are there in this? 76 minus 32. 76 minus 32. So 44. Right? 76 minus 32 44. Okay. If you take this one. If you take this one again 77 minus 33. 77 minus 33. Here also 44. So number of neutrons 44 here, 44 here. So isotone is this. So this is the option. Next. What will be the product of reaction? Given nuclei is this. Mendelevium 101, 255. Okay. In bracket plus alpha and minus 2 neutrons. Given like this. Okay, so options are, the first option is lawrencium 256, 103. Next nobelium 257, 102. Third one lawrencium 257, 103. Next one lead 82, 205. Okay. First of all plus alpha means you have to add minus 2 neutron means neutrons are emitting. Neutrons are emitting. So how you have to do this question? Dekho, first of all MD here 101, here 255 plus alpha 24. Okay, so it is given neutrons are emitting. Dekho, I am writing here 101, 255 plus alpha 24 given which nuclei will form? Y, Z, A plus 2 neutron 0 1, right? So answer is 255 plus 4 259, 259 equal to first of all A plus 2 into 1 2, A plus 2. So A equal to 259 minus 2, 257, 257. So first one is 257, A is 257. Okay. Next 101 plus 2 equal to Z plus 2 into 0 0. Z is this. So 103 equal to Z. So Z is 103. So 257 here, 257 here, 103 here. Lawrencium, right? So option is Lawrencium 257 103. 103. So this is the answer. Next, alpha decay of uranium 238-92 forms thorium 90-234. What kind of decay from 90-234 produces actinium? Simple. The question is here, thorium 90-234, thorium 90-234 is producing actinium 89-234, right? So which one will emit? First of all, here what? Okay, so the first option is alpha, second option is beta, third one is positron, fourth one is gamma. Acha. First, suppose if I take here beta or if I take alpha, देखो here alpha 24, what happens? 234 plus 4 equal to 238, but here 234, so alpha is not the answer. Next, beta minus 1 0, 234 plus 0 234, it is okay. 89 minus 1, 88, but here 90, so this is not the answer. Next, if I take positron, beta plus 1 0, 89 plus 1 90, 234 plus 0 234, so positron is the correct option. Positron is the correct option. Next, next one. Okay, X Z A, which is gives rise to Y Z plus 1 A. Okay, so what is the emission in this reaction? What is the emission in this reaction? Here, see, first suppose if I take beta particle here, right? If I take beta particle here, beta minus 1 0 emits, what happens? Z plus 1 minus 1 equal to Z, right? You will get this one. If you add this Z plus 1 minus 1, you will get this, so it is okay. Here A plus 0, A, you will get this, so answer is beta particle. For suppose you take alpha here in place of beta, alpha 2 4, what happens? Z plus 1 equal to 2, so Z equal to 2 minus 1, 2 minus 1 1, right? Here A plus 4, so but here A, right? So both are not equal, so the answer should be beta particle. Answer should be beta particle. Next emission, Y Z plus 1 A to Z minus 1 A minus 4. What is the emission? For suppose if I take alpha particle here, then Z minus 1 plus 2, right? So Z plus 1, okay. If I add these two things, I will get this one, okay. A minus 4 plus 4, minus 4 plus 4 get cancelled, A, so I am getting here A, so alpha particle emits. Alpha particle emits. Next, Z minus 1 A minus 4 2 Z minus 1 A minus 4. Which particle emits? Z minus 1, there is no change. A minus 4, no change. So gamma, right? Gamma particle, yes, gamma particle. Okay. Next, during alpha decay, first option N by P ratio decreases, second option N by P ratio increases, third N by P ratio remains constant, fourth option may increase or decrease. You have to take one example here. The example is, if I am not wrong, thorium 92-238, lead 90-234, and alpha emission is there. Okay, during alpha decay what happens? N by P increase, decrease, what happens here? See, first of all, N by P ratio 238 minus 92 neutrons. Neutrons means mass number minus number of protons. Neutrons 238 minus 92, that means 144 number of neutrons. Number of protons 92, so 144 by 92. Okay, so here if you get approximately 1.5 something, 1.58 something, you will get N by P ratio. This is N by P ratio. I am just calculating here. See, this N by P ratio 234 minus 90, number of neutrons 140 around, I think, right? 146 I think, right? And here by 90 number of protons, N by P ratio. So this N by P ratio, if you calculate, approximately 1.6 something. So what happens in alpha decay? N by P ratio increases. Calculate N by P for this, calculate N by P for this. N by P is increasing here. So during alpha decay, N by P will increase. During alpha decay, N by P will increase. Okay, for this type of questions you have to take example by yourself and see. Okay, next I am taking sodium 1123. Given a positron is emitted from this nuclei. Okay, then the ratio of the atomic mass and atomic number. So mass and atomic number. For suppose positron is emitting here. Positron means electron plus 1 0 or beta plus 1 0. I don't know which nuclei is forming here. Z, A. Okay, then what happens? You have to calculate ratio of mass by ratio of atomic number. Ratio of mass by ratio of atomic number. Okay, so first of all 11 equal to Z plus 1. So Z equal to 11 minus 1, 10. So here in place of this I will get 10. Okay, so my atomic number is 10. Next 23 equal to A plus 0. So A value 23, A value 23. Okay, so this is mass number, this is atomic number. The ratio of this, the ratio of mass number by atomic number, 23 by 10. This is the answer. Okay, so options are 22 by 10, 22 by 11, 23 by 10, 23 by 12. So the answer is 23 by 10. Okay, so these are the questions of this class. Okay, I will come up with the some more questions in the next class. Okay, so that's all. Thank you so much.